At the turn of this very decade, Apple released the M1 chip, its first Apple Silicon processor for the Mac. Overnight, performance, battery life and efficiency jumped to levels no one expected. But to understand why this moment was so revolutionary, we have to rewind. Let's go back to Apple's past, to a time before Intel, before Apple Silicon, back to the PowerPC days. In the 1990s, Apple relied on the PowerPC architecture, a collaboration with IBM and Motorola. PowerPC promised powerful processors and an alternative to Intel's x86 monopoly. For a while, it worked. Macs stood out. But by the early 2000s, cracks started showing. PowerPC chips ran hot, consumed too much power, and lagged behind Intel in performance per watt. Apple's laptops especially suffered. Steve Jobs famously admitted that a PowerBook G5 was simply impossible. In 2005, Apple made a bold move. Steve Jobs announced the transition to Intel processors. It was a seismic shift. Apple promised better performance, cooler laptops, and a wide range of software. Thanks to clever tools like Rosetta, old apps still ran. And suddenly, Macs could even run Windows. For over a decade, Intel-powered Macs defined Apple's lineup. But over time, Intel became a bottleneck. Progress slowed. Intel's chips grew hotter and laptop fans spun louder. MacBooks were criticised for overheating and throttling performance. Meanwhile, Apple had been building something quietly revolutionary: the A-series chips inside iPhones and iPads. Year after year, those chips rivaled and sometimes beat Intel in single-core performance, all while sipping power. By 2020, Apple had had enough. It unveiled Apple Silicon for the Mac, starting with the M1. Built on ARM architecture, the M1 combined CPU, GPU, memory, and machine learning accelerators into a single system on a chip. The results were staggering. Suddenly, entry-level MacBooks outperformed high-end Intel models, while lasting nearly twice as long on battery. And once again, Rosetta returned, this time as Rosetta 2, allowing Intel apps to run seamlessly on Apple Silicon. For most users, the transition was invisible, except for the jaw-dropping speed and silence of their new Macs. Apple Silicon did more than just speed things up. It unified Apple's product ecosystem. iPhone, iPad, and Mac now shared the same chip DNA. This meant developers could bring apps across platforms more easily. It also gave Apple full control over its roadmap, no longer waiting for Intel. Features like instant wake, hardware-level security, and incredible battery life became standard. Apple Silicon redefined expectations. Suddenly, thin and light laptops delivered workstation-level performance. Professional users embraced chips like the M1 Pro, Max, and Ultra. Developers, video editors, and 3D artists saw workflows transform. Apple leapfrogged competitors, forcing the entire industry to rethink what's possible in a laptop chip. Even Intel and AMD began emphasizing efficiency per watt, a shift sparked by Apple's bold move. From PowerPC to Intel to Apple Silicon, each transition reshaped the Mac. But the move to Apple Silicon wasn't just an upgrade, it was taking back control of its destiny, and in doing so, it changed everything. So that is how Apple Silicon changed everything. Thanks for watching, and I will see you in the next one.